Okay, let's start with properties involving the bounds of the integral. So, um, oh, hold on. Just going to work through a bunch of different properties and try to give some justification for them in these videos. So, the first one, well, imagine we have the integral from a to b, f of x dx, and we add the integral from b to c. Well, if you think about this as a picture, right? Let's say these points are A, B, and C here, and we have some curve, um, some function like this. This is our f of x. And this first integral represents this area here, right? That's that integral. And the second one represents this area. Well, you can probably guess where I'm going with this. This is equal to the whole area, the integral from a to c of f of x dx. So that one is pretty immediate. It's kind of nice, just the areas kind of go together. So that's the first one. Oh, I should probably, that was that area, and the whole thing, I don't know, the whole thing could be like that. Look how fancy I am with my colors. All right. So the second one, it's a little bit different. What if we wanted to integrate, instead of from a to b, what if we wanted to integrate from b to a, f of x dx? Well, if you think about it as sort of, let me draw like maybe in just a number line. And we're going, and if a and b are sort of in the normal order here, where a is less than b, well, then our sort of standard when we integrate from a to b, this integral here is kind of going, we're integrating this way, right? So our delta x each time is a positive number. So if we break up into if we think about the Riemann sum idea, then delta x, like a delta x right here, which we know is b minus a over n. Oh, oops. Let me just, the whole point was to talk about the integral the other way. Sorry, let me just talk about a general integral. Let me just say a to b. Sorry, I don't know what I was doing there. So delta x is b minus a over n. But what if we wanted to go the other way? So what if we wanted to integrate from b to a? So what if we wanted to say go this way, right? Well, if we think about sort of the Riemann sum idea, so that's like the integral, that's the integral from b to a of f of x dx. And the only difference is that the delta x, all the f of x's are the same. If we think about the Riemann sum, all the heights are the same for the points we choose. But now our delta x is, so this delta x was positive, but here our delta x would be a minus b over n, which would be less than 0. So the delta x's are all negative. And so basically, it's a different way to get a negative value for an integral. We had the idea that if the curve was below the axis, we could get a negative value. But here we're actually seeing a different way to get a negative value, which is integrate from right to left. So the directions, the signs of things, going up is positive, going down is negative, going to the right is positive, going to the left is negative. So basically what we're saying is this equals the negative of the integral from a to b of f of x dx. That's the property. This is the property right here. Switching the bounds basically makes the integral negative. Okay, not too surprising. Just as a consequence, or just not even a consequence, but kind of an obvious thing to say, is that What if we did the integral from a to a of f of x dx? I mean, you can give lots of different arguments. If you made a and b the same here, you get something equals negative itself. And the only way something can equal negative itself is if that thing is 0. Or you just figure the Riemann sum would be empty, right? You're actually not, the interval's empty. The delta x is actually 0. There is no delta x. So this is pretty clearly, this is pretty clearly equal to 0. So that's the third property. Okay, I'll stop there.